Hello everyone, in this question we will be solving question number 3 of internal paper number 3. In this question we are asked to list the error in computation of Simpsons and trapezoidal rule. Compare efforts needed for accuracy of Simpson rule with trapezoidal rule with 2 endpoints and n by 2 points with Gaussian quadrature. I'm assuming that you guys have basic knowledge of Simpsons rule, trapezoidal rule and Gaussian quadrature. Now we will move on to the solutions. Given function fx over an interval, let us assume that there is a function fx over an interval. A valid problem would be to declare whether to apply trapezoidal and Simpson's rule or a rule based on fitting a higher order polynomial. In order to make this decision, it is necessary to obtain formula for the truncation error. The error in using trapezoidal rule may be derived as the follows. Okay. So from here we can derive the error used in trapezoidal rule. Expanding f of x in the interval 0, h in a Taylor series, we will get fx is equals to f of 0 plus f dash 0 plus x square upon 2 factorial f double dash 0 plus x cube upon 3 factorial f triple dash 0 and so on. On substituting the value of x as h, we will get our equation number 1. Now by trapezoidal rule, the integral is h by 2. We know that f of 0 plus f of h is expanding fh in a Taylor series, which will give us h by 2 into f of 0 plus f of h, which is equals to h by 2 into f of 0 plus f of 0 plus h into f dash 0 plus h square f double dash 0 upon 2 factorial. And this is our second equation. The difference between equation 1 and equation 2 gives the error in applying trapezoidal rule. So the error is E is equals to minus h cube upon 12 f double dash 0 minus h to the power 4 upon 24 into f triple dash 0. As h is much smaller than 1, the dominant error term is the h cube term. Thus, if the interval at which fx is tabulated is half, the error would be reduced by an eighth. Now we will move to Simpson's rule. The error term in Simpson's rule may be calculated in the same way, and it is minus h to the power 5 upon 90 into fourth derivative of f of 0. Thus, rapid reduction in error makes Simpson's rule a favorite one for integration. Simpson's rule with n points gives about as much accuracy as trapezoidal rule with 2 endpoints. If cos quadrature is used, we may attain the same accuracy with n by 2 points. Thus, the computational effort required by cos quadrature is half as much as needed by using Simpson's rule. Now we will be solving the subpoints. There is no easy way of picking the interval in Gauss method. This is one of the drawbacks of Gauss quadrature method. This is to be contrasted with trapezoidal and Simpson's rule, where we are able to write an algorithm by using simple intervals. We may be given tabulated function already tabulated at equal interval, at which case only trapezoidal Simpson formula may be applied. Okay, so if the function is given in tabulated form, the Simpsons and trapezoidal rule can be easily applied. Okay, so this ends our another question. Thank you so much for watching the video.